All right, let's just jump right in. If you're building anything for the back end, you've probably been here, staring at a high concurrency problem, trying to pick the right tool for the job. And it often comes down to this classic matchup, Node.js versus Go. But you know what? There's a surprising truth about how they handle memory that's going to make you rethink everything.
So let's get specific. Picture this. You've got to send out 100,000 emails to your users, and you need to process them all at once. It's a classic concurrency challenge. Your two contenders are Node.js and Go. Now, which one do you reach for? Your gut instinct might be pointing one way, but I promise you, the real answer is probably not what you're thinking.
To figure this out, we have to start where most people do, with the surface-level answer. And this is where the picture gets a little, well, deceptive. It points you in a completely wrong direction.
Okay, so check this out. When you look at the basic unit of concurrency in each language, the difference is huge. A single promise in Node.js is tiny, just 200 bytes. A Go routine in Go, though, it starts at 2 kilobytes. That's 10 times bigger right out of the gate.
So your immediate thought is, whoa, Go is a total memory hog here. I mean, 10 times the memory for a single task? The choice seems kind of obvious, doesn't it? And if we do some simple math for our 100,000 email problem, it just seems to confirm it. Node.js would need about 20 megs of memory for all those promises. Go? A whopping 200 megs. Case closed, right? Node.js wins. Well, not so fast. This is exactly where the story takes a wild turn.
See, we've only been looking at one piece of the puzzle. We've been focused on the size of the task, but we've totally ignored the cost of the system that's running those tasks. And that hidden cost, it changes absolutely everything.
And this right here, this is the light bulb moment. It's the most important thing to remember. You can't just measure the task in a vacuum. You have to zoom out and look at the whole picture, the total memory consumption of the entire runtime.
And boom, here's the reveal. Just look at that runtime overhead row. This is the hidden cost we were talking about. Node.js, with its tiny promises, needs a massive 350 megabytes of extra memory just to manage everything. But Go? Its runtime is incredibly lean, needing only about 10 megs. So when you add it all up and look at the total memory, the script completely flips. Go is actually 43% more memory efficient. Isn't that wild? Now, if you're fascinated by how Go pulls this off under the hood, you should definitely subscribe to our Gokun channel for deep dives into Golang internals, architecture, and execution flow. Advanced concepts rarely covered on YouTube, and it's all available for free.
So you're probably asking, where does all that Node.js overhead even come from? Well, a few things. First, the V8 engine has to create a bunch of extra objects in the background for every single promise, things like closures and callbacks. Then you've got its garbage collector, which needs a ton of extra elbow room to work efficiently without grinding your app to a halt. And finally, the event loop itself has to keep this huge running list of every pending operation, and that entire list lives in memory. It just adds up really, really fast.
Okay, I know this can feel a little abstract with all the talk of heaps and runtimes. So let's use a simple analogy to make this crystal clear. Just think about it like you're running a hotel.
So let's lay it out. In our hotel, every room is a single concurrent task, so a promise or a Go routine. The big hotel lobby, that's your runtime heap. The parking lot outside, that's the extra space the garbage collector needs. And the back office staff area, that's where the event loop state is managed. So here's the deal. Node.js is like a fancy luxury resort. It has these really tiny, affordable rooms, our promises. But to support them, it needs this massive, opulent lobby, a gigantic parking lot, and a huge staff running around. The overhead is just enormous. Go, on the other hand, is like a super efficient hostel. Yeah, the rooms are a bit bigger, but the lobby is tiny, the facilities are shared, and it's mostly self-service. The overhead is absolutely minimal.
And that brings us to the core lesson of the whole analogy. When you're picking your hotel, the size of the room doesn't equal the total cost of your stay. You have to account for all the other stuff too.
Okay, analogies are fun, but let's bring this back down to earth and talk about real-world consequences. What does this memory difference actually mean for your application's performance and for your bank account? Honestly, the impact is just staggering. Take a standard server with 1 gigabyte of RAM. On that machine, Go can easily handle 500,000 concurrent operations. Node.js, because of all that overhead, it hits a wall at around 50,000. Just let that sink in for a second. That's a tenfold difference in capacity on the exact same hardware.
And of course, that difference in capacity translates directly to how much you pay. To handle that same high-traffic workload, you might need a whole cluster of Node.js servers, costing you, say, $70 a month. But with Go's incredible efficiency, you could probably run the whole thing on a single small instance for just $17. The savings are huge.
So what's the big takeaway here? After all of this, what should you remember the next time you're starting a new project?
It all comes down to picking the right tool for the right job. Look, if you're building something that's going to have pretty low traffic, the simplicity and the massive ecosystem of Node.js make it a fantastic choice. But if you know you're building for high concurrency, we're talking hundreds of thousands of simultaneous connections, then Go's memory efficiency is going to give you a massive advantage in both performance and cost.
So I'll leave you with this one final thought. The next time you're comparing technologies, don't get distracted by the shiny surface-level numbers. Step back and always ask yourself this question. Am I just looking at the cost of the task, or am I looking at the total cost of the system? Because as we saw today, the answer to that question can make all the difference.